I hope you are in a position too. So yeah, we start. Open for us the meeting.
Okay, thank you, Senior. May we bow down as we pray. Our Father in heaven, we come unto you this time, thanking you for the gift of life. Thank you for enabling us to meet here again. And as we are going to start this important session, may you be our guide. Go before us, go before our presenters. Bless us all, and in Jesus' name we pray and believe.
Amen. Amen. Welcome, guys. The yesterday's recording, it is ready, and we are going now to put it in a best way we can share for you to watch later. So those who are asking for the link immediately, it was not possible because you know who has to process this recording, and it's a very huge file. So walinitumia asubuhi ndio wamenitumia hiyo link, hiyo file. So with this one also, by tomorrow it will be ready. We are going to share with you so that you can watch at your convenience. I hope that's okay. So in today, we are going to have two sessions. The first session will be done by our senior Nyikuri, and the second session will be done by our senior Libendi. And if you remember in the group, I told you, you come with calculators. Those who will have managed to access them, you come with your calculators. So session 2, we are going to be taken through Libendi, and it will be all about something he has planned or he has prepared for us. So I want to hand over the mic to our first presenter.
Thank you. Good evening, colleagues. Good, hope you are fine. So this is the second session of Math Paper 2. I want to take this opportunity to welcome you all. So the Math Paper 2 has no much deviation as per the Math Paper 1. So most of the items were mentioned in Math Paper 1, which are the same thing that are captured in Math Paper 2. So maybe I'll just try to remind ourselves some, and then the rest of the time we'll just give a session for the teachers now to ask the question they were asked yesterday, so that at least now we can try to simplify more and more the details in that paper, Math Paper 2. So the Math Paper 2, which is given the code 121/2, it is a paper that appears sometimes to be very difficult, but it's also another paper which is a very easy paper. Hope you are right. Can confirm, moderator? Are you able to see my screen? Moderator, can confirm?
Yes,
are you able to see my screen? Good. So this Math Paper 2, there was just some changes in the setting. For the last 5 years, it was more of the procedural knowledge, but currently it is now testing and pivoted under the concept which the student has. And the way this paper is set, it is mostly of paper Form 3 work and Form 4 work. This paper is a paper a student can score everything because it caters less number of topics. Remember that math topics from Form 1 to Form 4, we have a total of 68 topics. Out of the 68 topics, it is only 21 topics that test in Math Paper 2. The 15 topics in Form 3, 2 are for the Paper 1. That is solution of triangles under trigonometric ratio 2. And we have the matrices, that one goes for Paper 1. So out of 15, we are remain with 13. Then the Form 4, we have 10 topics. Out of the 10 topics, 2 topics goes for paper 1, that is differentiation and area approximation. So out of the 10, we are remaining with 8. So the 8 plus the 13 topics in Form 3, we have a total of 21 topics. So with that reason, the topics that are remaining, they have equal chances of all of them being tested. So we don't have the specific topic that this topic is the one that is can maybe come this year, not next year. No, they have equal chance of being tested, and even some being tested twice. For example, when you take a topic of formula and variation, we can test on making a subject or the subject of the formula, and also on the variation tested twice. We can have a topic on trigonometric ratio 3, testing the solution of that trigonometric ratio, and also we test on the graph. So they have, because of the less number of topics, these topics can be tested more than 2, and all of them, they have equal chance of being tested. So with that reason, if a learner is revising for the paper 2, let us not give them the specific topic to go and revise. Just like paper 1, we cannot, we can tell them don't revise things like divisibility test, because those are the things they can maybe master without knowing more details in it. So the structure of the paper 2, the Form 3 work. Form 3 work normally contribute at most, let me use the word at most 12 questions in section 1. And we have some of those topics that we can identify that these topics cannot come in section 2. For example, SAT. We cannot test SAT in section 2. Those are the areas that we expect in section 1, and so other topics like perfect squares. If they are perfect squares solving using completing square method, those are the things we don't expect in section 2. Solution of trigonometric ratios, that is Form 4 work, which is under, for the Form 4, I've said that there are 4 questions that we expect from Form 4 work. So for the section 1 alone, we have a total of 16 questions that are tested. 12 questions in Form 3 and 4 questions in Form 4. When we come to section 2, the section 2, they at most share equally. The 4 for the Form 4 and 4 for the Form 3. We don't expect a question from Form 2 and Form 1 for paper 2. So the paper 2, when I check this structure, you'll find that the Form 3 is the backbone of math paper 2. So a student who is able to revise Form 3 book well and master that content in that book 3, the student will be able to secure at least 60 marks and above, which is just the concept that we understand, things like approximation and error. How do we approximate the error that makes maximum and minimum? Yes, good. The common mistake, we also mentioned yesterday about the common mistake, like the omission of works. The work like on vectors, when you avoid those symbols, the symbols for the vectors, and at the end you score the whole workings correct, we will mark it correctly, but now we'll deny you 1 mark, unless there is where even one of the workings you captured there, a vector symbol, will not punish you. But if you avoid completely that symbol of the vector, a learner will end up losing only 1 mark, but for the correct workings. If you work them wrongly, will not penalize you. But if you get the whole mark, then student will now be for meeting work. We deny that student 1 mark. Premature rounding off, we also discussed about it yesterday, where you can just do some approximation early. Like for example, when you are asked maybe the distance along the circles, the arcs, then you decide to pick your own radius of the arc, because sometimes they can decide not to give you that common radius of the arc. So the common radius of the arc is 6371 from the mathematical table. So we expect a student, if not given they just copy it from the mathematical table. But whenever a student decides to go for 6370, because she or he is aware that it is 6370 that is divided by 7, that 6370 being an approximated radius, a student will be booked for an premature rounding off on the final answer if the student is able to secure that mark all of them correctly. So if you fail, well and good, but if you score the whole marks, you will be booked for that 1 mark for premature rounding off. Then we have another one on the method error. The method error, you will lose all the marks. For example, if you can be given a quadratic function, then the question asks us to carry the solution of that quadratic function using a completing square method. But now a student decide to go ahead and solve that quadratic equation. Instead of using the complete square method, the student decide to use a quadratic formula or product sum rule so that they can factorize out, then come out with values of x correctly. The student will be denied all the marks for that method error, which was not the expected method of working out that question. So the student will lose all the marks. So if the question asks us to use a complete square method, clearly we need to see how that student is able to show how we complete the square method. That's where we'll give the M1. But once there, the student opts to go for the quadratic formula, the student will get their M0. And once we have their M0, the remaining will be M0, and then finally the A0. We cannot have the M0, then the others are correct. No, that one only happened in paper 1 under factorization of the expression, and also maybe question number 1, maybe when the numerator is correct and the denominator is wrong. You can give M1 on the numerator and the M0 on the denominator, or the M0 on the numerator if wrong, but the denominator if correct, we will give M0, M1, A0. That order is acceptable in paper 1. But in this one, once you mess with that method, that you have been asked to use the complete square method, but you opt to go for the quadratic, you will get M0 and the rest of the work will be M0, like that. Like this one. This was using complete square method. This student will be able, this student A will be able to secure all the marks, because first of all, the highest power, which is 2, is coefficient is 1. It's just to add b over 2 on both sides, like that. So once you do this, the student will secure there the M1. But take the student number B. This student B. The student B decided to go for the quadratic formula, even if the final answer are going to be all correct, which is the value of x is 7 and -2. But having a wrong method at the introductory of the workings, the M0 will be followed by those other awarded 0, 0, like that. So the wrong method, the student will secure the 0, like that. Then we also discuss about the answering more than 5 questions in section 2. You know, in section 2, in fact, they normally use a very polite language in mathematics. They don't ask students to do all the questions. They just ask the student that attempt any 5 questions. That language, polite language, attempt any 5 questions from this section. So being that word attempt, it means that in case, when does this student say to be attempted this question? A student will be said to be attempted this question if and only if, number 1, the paper came, then it is collected back with a different ink that was earlier on that paper. Check like this example. When you check this example, the student decided to scribble here with a pencil. This question number 17, which was in section 2. So the student was trying to see if the question can be done. But at the end realized that even if in recalling those formula, let me use the one that is in ink, even if in writing the formula, the question is not adding up, the student decided to leave that question now and then go and do another question somewhere. So because this ink that is scribbled there, it was not part of that question question when the paper was submitted to the student. That workings, even if it is one sentence or just a letter, one letter, it will be considered as a way of that learner attempted that question. So in that scenario, a student should cancel that question fully, not the part that has written alone. No, if it was question number 19, she canceled the whole page from the corner to the corner. And when you are canceling, you make sure that your line passes through the writing, because sometimes students normally cancel their work, but the line is not passing through the writing. If the line is not passing through the writing, then those writing will just be considered as your workings correctly. So you make sure that your line of cancellation, if you check that, maybe drawing from the top right hand side corner to the bottom left hand corner, that line will not pass through the writings. You can cross from now the left top corner to the right bottom corner. You make sure that that line of cancellation passes through that writing, because if they fail to pass through them, then the writings will be considered and it will be marked. Then simplified equation, we also discuss about them in paper 1, that we don't mark an simplified equation or fraction. The only place we normally allow the unsimplified fraction, it is only in probability. Probability, we can allow anyone who can write an simplified fraction like 100 over 1000 in probability is acceptable. But any other workings of the question where you have not simplified completely by dividing through by the common divisor on that expression or numericals, then a student is going to lose an accuracy mark. And remember that this accuracy mark accumulatively, when you consider them, they are totaling to 21. So 21 is like a student being marked out of 79. So let us encourage them that let them just pick that fraction the way it is, fit in the calculator. If it's numerical, then press is equal to, then we have a pattern for converting into fraction, so that the calculator can give them a simplified fraction instead of struggling checking what is the common divisor, and they have the calculator. Like here, we had here a wave equation of which it was used as an example in paper 1, but this is a paper 2. This question was stated in KCSE 2018 in math paper 2, where students were asked to just determine the amplitude from this graph, from this wave. So the amplitude is just the coefficient of our trigonometric ratio. But when you check our coefficient of that trigonometric ratio is 3/2. So a student who give 3/2 as his or her answer, the student is going to score B0. Why? Because 3/2, it is unsimplified. The simplified form should be 1.5, or student give 1.5. But this one is as per my presentation. But for student, let student not give the alternative that 1.5 or 1.5. No, let just student give 1.5 is enough. Then there was another part on this one which was asked about the period. The period, it comes from the angle. Both period and face angle comes from the angle. So we need to check this trigonometric ratio as well. This trigonometric ratio, we have what's called a parental part, just like what we did in chemistry when we were in organic chem. We have the parent, which help us in naming. Then we have the branches that can now help me to put that hyphen or methyl, what is or ethyl. So the trigonometric ratio also behave like that. So the parent of this function that is here is sine. It is sine. If it is cos, that's why I normally say that the sine wave or the cosine wave or the tangent wave, the tangent. So the parent of this equation is sine. If it is cos, the parent is cos. So all the remaining things we normally get from this parent, the remaining are just the branches. And the branches are the one that will help us to get the amplitude. The branches are the one that will help us to get the period. And the branches are the one who will help us to get what's called the phase angle. So the period, you'll find that after the trigonometric ratio, that part is an angle. The whole of it is an angle. Sometimes that angle can be a variable with the coefficient, or it can be a combination of an angle with a variable with an independent angle. an angle with a variable with an independent angle. So from this one, from the sine to this other part, we have 2 theta and 30. All this one are angles. But the one that has a variable, which is theta here, is the one that will help me to get what is called the period, where you take 360 divided by the coefficient of that variable theta. But now the independent angle is what normally gives us what is called the first angle, but you take its absolute, so that if it's a negative, you'll have to drop its negative. Though we have some books that are saying that you take this, like this case, you take that divided by 2. No, that's not correct. The correct one, the first angle is this independent angle that has no variable. That one will give us the first angle. But the one that has a variable is coefficient. You take 360 divided by is the coefficient. That one will give us what's called the period. And the coefficient of the trigonometric ratio, that one will give us what is called the amplitude. And another constant there, it will give us what's called the phase shift, which we don't cover in the high school level. This is their workings. This student B has given us 3. Simplified, that student not get it. It will be B0. Like this one, making R the subject formula, you'll find that we have a common divisor on the numerator and denominator, which is -1. So the student was supposed to divide by -1 on both sides, so that to eliminate this negative from the numerator. But the student left the answer as -q over -xt minus k. So that one will be counted as unsimplified. So the student is going to lose the accuracy mark for leaving the answer unsimplified. But this one is going to secure all the marks because it was able to divide through, to multiply through, or divide through by the common factor, which is -1, to end up with the q over x2 plus k. The student B is going to secure the whole marks. Construction of parallel line in loci. Some students normally lose those marks. Like when you take cases 2019, where students were able to were given how to get a loci whose area was given, that you have been maybe you have been given the triangle ABC, you have been given the dimension and the angle, you are able to come up with that triangle. Then once you come up with that triangle, you are told maybe on the same side of this one as this. Identify the loci of this one, and you have been told the area of that loci, meaning that that is a parallel loci. So if it's a parallel loci, this thing of using the arc at a point whose distance is equal to that perpendicular distance from that baseline is not the accurate one. Sometimes students can easily miss. So it is advisable if you are told to construct parallel line. This is the best method. For example, a parallel line to this line AB. You can decide either at A or at B, or anywhere within this baseline to construct a perpendicular line. Then along that perpendicular line, you can mark off the radius at which those parallel lines should move. Like this one, from A, I marked off the radius up to this arc, maybe say 4 centimeters. Then where that arc is cutting this perpendicular, you use that one again as your center. Then you draw a perpendicular through that point. This is the best and the accurate way, and is the one that is advisable in using when you are drawing the parallel line. So when you go back to class, please let us advise students when you are drawing the parallel line. When we are drawing the parallel line, let us avoid those one of using the arcs, because sometimes the arc might be incomplete. Being incomplete, and then you join at the top as the touched, it might end up with a wrong parallel line. Then another thing, it is about the incomplete proof of collinearity. You have been asked to in vector to show that the points are collinear. Students normally keep those conclusion incomplete, because one of the first thing you need to do is to express one vector as a scalar of the other vector. Once you express as a scalar of the other vector, then you can now generalize that it is parallel. When one vector is expressed as scalar of the other one, that is showing that they are parallel. Then among that statement, again, you can check that there's a common point. You state that common point. Then you conclude these are collinear. And then now the challenge comes in finding the scalar. When you are finding the scalar, you don't test only one corresponding element. You need to test all the corresponding element. Like in paper 2, it is a 2-dimensional, not a 2, it is a 3-dimension. When you take this example, you are asked to confirm that these points are collinear. This one means that I can find AB and AC, then express one as a scalar of the other one. So when you check the workings here, I find AB, I find AC, then I express AB as AC. So when you are relating, you don't just use 2 is equal to 6K. Then once you get K, you stop there. No, you also need to show the other one so that at least clearly you are sure that all the points can be expressed as a scalar of the other, because it can reach a point where you can find that element in the first row, they are giving a scalar K 1/3, and only to find that when you test the second row, it's not giving the same 1/3. So when during testing to get that scalar K, test all the element, because one of the element cannot maybe satisfy that condition of the one you have called the first 2K. So if they are not satisfying, it means that the student will have now to say the points are not collinear. But this case, both were giving the same K, which is 1/3. Now from there, AB is equal to K. Instead of K, we place there 1/3 AC. So once it is expressed like this one, they are parallel. And from this one, A is common. Don't struggle to go ahead and find the ratios. No. Once I have this statement of parallel, from this expression, A is here and also A is here. So in this one, A is common. So once I have shown that it's parallel, I have shown the parallel common point, I now conclude A, B, and C are collinear. A, B, and C are collinear. Yes. Sawa. Another mistake that we normally do is commitment for your own work. A student normally went ahead and commit for his or her own work. So I have tried here to write here some of the cases where students normally commit themselves, but sometimes during NEC, we normally just place a human face and forgive them. But these are the serious mistakes students should never do in the mathematics. Take like this student A. He was asked to get the percentage error. In this question, we don't have anywhere where the number of decimal places or accuracy level has been stated. So the student decided to come up with this one when you divide, but he or she went ahead and decided to round off. But during rounding off, he did obey that rule of at least 4 significant figure. So in marking, the accuracy mark normally come at the early stage. The accuracy mark should come at early stage. Like here, the early stage is here. But we find that some student can go ahead after K 0.67 anapigia hiyo mstari kuonyesha kwamba is restricting an examiner kwamba this is my answer. So he tried or she tried to underline that answer, or she went ahead even if she went ahead and write there answer. That is, you are restricting an examiner that however you are marking, my answer is here. So when you do that, sometimes we just place what's called the human face and leave your wrong answer and mark up to the first point where the early stage of the exact answer comes in. But for this one, maybe, you know, when you check the marking scheme, moderated marking scheme of NEC, in that column, they normally say that allow, or when we are discussing the marking, they just say that allow for the student who have done that. But that point of saying allow, it does not necessarily mean that during that year, if we allowed that, it is the correct method to work out. No, it was just shown maybe for that particular year in favor of the student because maybe of the how human we are during that year.
So we might allow something this year only to find that next year the same mistake will repeat and we penalize. Take an example of KCSE 2009. KCSE 2009, under an ogive, students were allowed to use a graph that starts from negative 0.5 when they are using those boundaries. But come case is 2022. The case 2022, those students were denied marks. So something that I've seen allowed this year, if it was an additional on the scheme, so that in favor of the student, we cannot use it so that in teaching, we tell them that we also, this one is acceptable. No. So this student who commit up to this point, though we normally allow to mark up to the earliest stage, but that allowance, it means that it is the correct way, it's the correct way to go. Because this student ameenda ahead, amekwambia, this is her answer, like this one. Paka amekuandikia hapo, answer is equal to. Now, who are you to mark the mark up to this first stage? No. It might reach a point where it will be turned. Then we say that if the student has said that that is the answer, why can't you mark her answer, which is wrong? So if you come across a student, let us tell them avoid underlining the answer. Let them not have that habit of stating that this is the answer. Because, by the way, they are working without knowing the answer because the marking scheme is in the neck. They are just trying to follow the correct procedure if they can get the same answer, but they don't know the answer. So if they don't know the answer, let them not in the restrict examiners that is the answer. Let them leave and open like that so that the examiner can go ahead and choose for them where the answer is, where the mark will come at the first stage in that question. We also have a problem on the SI unit. In mathematics, we don't allow students to give an SI unit, but if they give, we will mark. But the problem with the SI unit is that when the student give a wrong SI unit, the student has committed herself. For example, take an example in kinematics. I have here a question on kinematics. The student has been asked to get the distance, whose SI unit is meters. Then she has integrated very well in that time intervals and then get the answer, which is correct. 10 whole number 5/6, which is a correct answer. But the student now went ahead and give an SI unit as meters per second, which is not an SI unit of displacement. So with that reason, the student is going to lose an accuracy mark. An SI unit in mathematics is not marked, but when wrongly used, we are going to mark it wrong, the way you have used it wrong. So my advice is that when these students are giving answers in mathematics, the only quantity we allow them to give an SI unit is number one, is time of the day. Time of the day is either AM or PM. That one are allowed to give an SI unit. Number two is on angles like bearing 10 degrees east, 20 degrees west. Those angles in the latitude and longitude, that one they are allowed to give the SI unit. But all the remaining quantities, let us discourage them from stating the SI unit of those quantities, because they might state the wrong SI unit and the answer was wrong, was correct. The student is going to lose an accuracy mark, the way this one has lost the accuracy mark by placing their meters per second. Accuracy level, that one we also discussed about yesterday, that the last answer, if not stated the decimal point or significant figure, give your answer in at least 4 significant figure. And where do we take time to get to check if it's at least? Let the student just copy the whole answer on your calculator display. Your calculator you may display too. Let that student copy the whole answer. Na hiyo mambo ya at least yenyewe itapata huko mbele, because the calculator already gives in that list for significant figures. So let the student not avoid rounding off when the question has not done demanded to do so. Like that. Good. We have another area we have to check on, that is on commercial arithmetic. That's a gray area that it is raising so much question. The taxation. You'll find that this taxation table, as we are going with the current we are having, economy we are having in Kenya, the table is going on expanding from time to time. Like 2020, there was another expansion that was added on the pension scheme, where the person was subjected to a pension scheme that was contributed, and it was given as a 7.5% that was contributed to the pension scheme. Recently, they have introduced these things of housing levy. You never know. You know, the setting of the KCSE is with the current trend with the life happening in our country. So they have introduced these other things of the housing levy. The housing levy, it is around 1.5% of the gross income, not of the basic salary, but sometimes the question will direct is of what. So some of these things, they are doing so, and they are saying that they are not taxed or they are exempted from taxation. So with that reason, we need to advise students that during calculation of taxable income, let them not start directly from taxable income. Let them start from the gross income, where the gross income is the basic salary plus all the allowances the student has in that question. Even if it is non-taxable allowance, the student should add to get what's called the gross income. Then after getting the gross income, from this gross income is when now the student will have to get what's called the taxable income, the amount to be taxed. And the amount to be taxed, now the student has to subtract what is exempted from taxation, what is non-taxable, to remain with what is called the taxable income. So the taxable income is the one that is passed through the slabs up to what we have what's called the gross salary, the gross tax. So once you get the gross tax, you can get what's called the net tax or tax paid. Then from there, the last part can ask a student to calculate what's called the net salary, which the person will pocket at the end of the day. Now, when you want to carry the net salary, we go back to the gross income, not taxable income. The gross income minus total deduction. Now, how will this student know the total deduction? The total deduction, let this student not check the one that is written in that part. No, the student should go back to the question. Anything that is said contributed, anything that is said to be deducted, anything that is said to be paid, that is a deduction. So if there was a pension scheme that was contributed is like you are reducing from what you have, giving out. You are giving out. And when you are giving out, it is you are reducing your gross salary. So it is also a deduction. Ukiangalia kwa hiyo swali, you can have somewhere maybe like a person is entitled to an insurance relief, which is taxed on the monthly premiums paid. Because of the word paid, it means that the premiums are also the deduction, like that. So from that taxation table, we have that things that we need also to consider. We had here an example. I used this one in that year. Ms. Nyukuri earned a monthly basic salary of that one, medical allowance of this one, a house allowance of that one, commuter allowance of that one, and a non-taxable hardship allowance of that one. Then Mr. Nyukuri contribute 1.5% of his gross income. It is of gross income. Let the student read the question. It's not of the base salary, gross income. And I've said that gross income is base salary plus all allowance. Gross income. Contribute 1.5% of his gross income made every month for the affordable housing levy fund. This contribution is exempted from taxation. He has a life in foreign policy for which he pays a premium of wisdom. Unaona he pays. So that pays, it means that 4,500 will also act as a deduction when you are getting what's called the net salary, like that. So that was just an example. We have another gray area in geometric construction. In geometric construction, number one, all the angles that are divisible by 7.5, the angles must be constructed. If you test your angle is divisible by 7.5, the student should check a way on constructing that angle. But if the student is unable to construct that angle, haina shida. Let the student take a protractor. Let the student measure that angle. And one the student should not place any arc on that line, because that is a line that is obtained by drawing, by measuring. It's not by construction. So let the student not forge the arcs, so that to show that because they say they're using a ruler and a pair of compass, let me forge the arcs. No. You play the arcs, we'll need to know where was the center for those arcs, and if the center is here, was the correct process of obtaining that angle? No. So if the students are able to get that angle, let student measure using the protractor. So once you measure using the protractor, getting that question correctly at the end will only deduct you 1 mark. So if it was a question of low side 10 marks, a student is only going to lose 1 mark and remain with the 9 marks, instead of forging the angles and then coming up with the things that are not acceptable in this mark. Challenge. When you are plotting a graph, you know, you will be told in most cases that during marking, so those who have been in this field of marking, you will know that students normally perform poorly in graph. Why? Because of these things of plotting. If you have come up with a scale on a Cartesian plane, before you place a point, a student should be in position to identify what is the least unit. What is the least unit of that axis on y-axis and on the x-axis separately, so that when you plot exactly. Most of the time, like on trigonometric ratio, some students normally get a challenge in plotting 0.87. Instead of plot 0.87, they normally plot 0.8, and others normally plot 0.9, which is not the correct one. So 0.87, you'll find that it is between 0.8 and 0.9. So any plot between, the student will secure that mark. But a student who will plot at 0.8, or a student will round off and plot at 0.9, the student will not get that plot. The plot will be wrongly placed, and the whole graph now will be called wrong for plotting. And when the plotting is wrong, it means that the curve is also wrong. So let us advise them in calculating this division and in a least rating of 1 division. And once you get the least rating of 1 division, if the number of division is a half, it is in fraction or decimals, let them not round off. They should place between where that fraction is lying. That was an example of that graph. And they should also be very keen with those troughs and crests. It is a curve. It is not flat. It is a curve. So that if it is standing, like being a straight line, they find a way of getting that curve. Yes.
Senior.
Yes, senior.
Maybe they're saying maybe you could go to slideshow so that it would allow the font is small. They're saying.
Oh.
And go to slideshow.
And I think on this, I'm on the slideshow. I'm on the slideshow.
No, go to.
I'm here, slideshow.
Click hapo juu, unaona kuna from beginning, from current. Click hapo juu.
There. Is that one now okay? Let me check. Let me see. Good. Let me see. Now I need to go back where I was. Good. So we have a debate on these things of an ogive. An ogive, it is drawn from statistical data. Statistical data, they have what's called classes. The classes. It might be given in raw data so that a student come up with what is called the classes. But these classes, they are of 2 types. One is called apparent classes, which commonly we normally call it as a continuous. We have continuous classes and apparent and continuous. So the one that you normally call them continuous, they are not called continuous. They are called real. And the one that we call them that uncontinuous are the one that are called apparent. Now, what are the real? What is the difference of the real and apparent? The real, remember that these classes have end. Kuna yenye imeanza na kuna yenye inamalizika. That is end. So when you check the end of the upper end of a class is overlapping, that is the end, and the lower end of the 2 consecutive classes is overlapping. like KCSE 2011, KCSE 2011, question number 18. It was running from 100 to 150, 150 to 200, 200 to 300. So you'll find that the upper of the first class or preceding class is the lower of the succeeding class. They are overlapping. In that scenario, it is called the really classes or the continuous classes. And if those ends are overlapping, now their name is called boundaries. They are not called limits. They are called boundaries. Boundaries is where the ends of the upper end and the lower end of any two consecutive classes is overlapping. Those ends are now called what? The boundaries. The upper end is called the upper boundary and the lower end is called the lower boundary. That's how we identify the boundary. But where the ends, the upper end and the lower end of any two consecutive classes are not overlapping, then that one is called what? The limit. For example, a case of 10 to 19. 20 to 29, you'll find that the first class nimetoka 10 to 19. The second class to start, I've started with the 20. So the upper of the first class, the upper end, I've stopped at 19. And the lower, starting with, in the second class, I've started at 20. They are not overlapping. So in that case, if they are not overlapping, those ends are called limit. And drawing of an ogive, we don't use limit, because if you use a limit, you will have a gaps. We will have a gap because of non-continuity of that curve. So we normally use what is called boundaries. And at the origin, we start by the lower boundary so that at least we can avoid the breaking of the axis. So you just check from your first class, what is the lower boundary, of which the lower boundary we can calculate it. You get the lower boundary. So the lower boundary is the one that will start at the x-axis. At the x-axis, let me get there, I'll just show. So the lower boundary, you start it at the lower bound, at the origin. Now the question will be, what about the lower boundary is taking you to the negative, like that one of KCSE 2009. So when it starts from the negative, when you allocate the boundary and start from the negative, check the type of the data that you have. Is the data talking about the temperature? Is the data talking about the max? Is the data talking about the mass? And find that in mathematics, most of the time they normally use max. If it talks about the max cannot be taken to the negative side. Max, yes.
Google slide number.
I'm trying to check. I'm trying to go back where I stopped.
Please take us there. We can't see. We can't match the presentation and what is in the screen.
Allow me to control him.
Okay.
Yeah. Was screen to slide 43. I don't know if that's correct on your position.
On my side, it is on 21.
No, refresh now.
So
on the screen, it's 40.
On your side, it's on page.
What you do?
Yeah.
Stop setting.
Yes.
Stop.
Oh, okay. Let me just
again. You come back again, as in you stop the mini presentation, screen sharing.
Let me check.
Now we are seeing
That's
these vectors. I think size number 22.
Stop sharing. Let me now reshare again.
Share again.
Good. Are you able to see my site now? Let me see this. Let me go back to that slide. Down, page down. On your side, it's showing slide number
5.
5. Good. You are now together. Let me check. I want to go back to that slide number 43. Where can I press? So
just next arrow. The arrow.
Oh, let me just use the arrows. I thought that maybe I could be having somewhere where I can just press and then I go to that slide. Good. Let us just be patient a bit. Slide 4 towards 3.
Is it moving?
Hey. I'm now at 17. Hope you are able to see 17 on your side.
Press escape to disable the slideshow first. Rudi uko normal kawaida. End the slideshow.
I have ended. I think I have ended good.
Wait, I confirm. Let me confirm with someone else. Daudi, what are you seeing on the screen?
Are you able to see the graph?
Yes.
Good.
Okay.
Now the problem is that when I go to the from beginning, I'm a slideshow from the current.
Beginning from the
From
current.
Yes.
Current.
Yes. Beginning.
I can see the ogive curve.
Good. It is there. Let me see its display. Now it's not displaying the ogive. Or you are seeing the ogive on your side?
No,
Enter.
we can't see the ogive.
Yes. Are you able now to see it?
Yes.
Good.
Yeah.
Yes.
So from this one, I started by the lower boundary at this origin here. The lower boundary of the first class is the one that you need to start it with here. And that lower boundary is frequently 0 because it was the upper boundary for the previous class, which was not there. So I start by the lower boundary is frequently 0 so that this curve can be anchored there, not somewhere here. And the upper boundary of the first class, the frequency that is there is for that upper boundary. Now the question is that what about if your data is taking you back to the negative? What will happen if your data is taking you back to the negative, like this one? This was for the KCSE 2022, like this. You'll find that these values are not overlapping. The uppers and the lower between any consecutive classes are not overlapping. So to make them overlap, I need to add maybe 0.5 and then here I subtract 0.5. But when I subtract here 0.5, I'll go back to negative 0.5. So the negative 0.5 and this data was for the height. Check here, it is for the height. Height cannot be negative. So we cannot go back to the negative. So we need to start from 0 because 0 is an absolute. So I want to emphasize something here because I came across some workshop where teachers were told that you can avoid placing here 0. Let me go back to this slide, the slide that is there, our table that was there, like this. You can avoid here because it was 0 to 4. So the lower boundary itakuwa negative 0.5. Then the upper boundary of class itakuwa 4.5. So we don't want student to place here negative 0.5. The situation is low, which is the lower boundary. I've said that because the data was height, you cannot start by the negative. You start by 0, which is absolute. But in the sum of the workshop, some teachers were told that you can avoid to place here 0 so that the 0 is only for the y-axis. You extend this one at the intersection of y-axis and x-axis. You extend so that it is only this line that is extended here that have 0, but the y-axis that is extended downward, you don't put there anything. Then here, you write there 4.5, 9.5, 14.5, which is true. It is correct because the student has not committed himself or herself that it is negative or 0 and he has used the uniform scale. But that one, it can only be allowed in a particular year depending on the case of that during the coordination. So though it can be acceptable in some case, but let us not risk our content to do that. Let them not risk. Let them start from 0. Then use a uniform interval. But during plotting, let them plot at 4.5, but not at 5, because the 5 is for the scale. but the plot was to be placed at 4.5. I want to repeat. In the workshop, we are told that we can avoid here placing there 0, then we use 4.5 because it was a shorter way. Some students have had challenge in plotting 4.5, 9.5, which is true. But I want to confirm you that that one can be allowed. It is under allow when we place a human face. But who will be placing human face every time? No, we will not be placing those human face every time. We can reach a point where we can say, no, just deny student, that student a mark. We cannot put ourselves in the show for the student to feel for her or him the value there that it is there. Because even if you move a scale backward, it will take you back to negative 0.5, which is not acceptable at that origin. So let students start by 0 because 0 is an absolute. That one, I think you will ask if you have not got it, will come across under the question. Transformation, I think we had already talked about them, that the scale on the y-axis must be the same as the scale on the x-axis. Then under these transformations, the transformation, because it is a topic that is done separately in the shear stretch in paper 2 and in paper 1, reflection, translation, and so on, we don't test students on the things of transformation in trigonometric ratio. It was lastly captured in the KLB, the third edition, but check the current one. It is not there. So when you check the syllabus, let us not task our student indicating the transformation of those trigonometric graphs. No, let the student just use what they have in transformation. They should just understand what is shear, what is that's shear, those unit squares, mastering them. When the y-axis is invariant, that is our unit square, where k is our scale shear stretchy factor. That's something they should also note, and which is very easy. Then in describing the shear fully, students should give what is invariant line, what is the point, that image point, so that at least to secure that mark for complete description of that thing, that the graph, the scale must be uniform on both y-axis and x-axis, because if it is not uniform, a square drawn can look like a rectangle. Like here, this is a description. It is a stretch. I'm saying it is a stretch. Number 2, the student has stated the invariant line. Then again, he has added what is the scale factor, which is -2. But you can also add n of 1 point that has moved from object point to image point. Then we have also another thing that is coming in on this transformation. A good example case is 2020, where student can be given image point, then denied an object point. You are given the matrix that has transformed object point to an image point. Then you have been given the coordinate your image, but denied the coordinate of the object. Then the first question asks us to carry the coordinate of the object. Remember that when I'm moving from object to image, that is forward. When I'm moving from the image back to the object, that is a reverse. So a reverse of that matrix is the same as the inverse of that matrix. So instead of a student applying that, let that object coordinate be ABC, so that the student can come up with a simultaneous equation. If you have image point and the matrix that map object onto that image point, just find the inverse of the matrix. Then once you get the inverse of the matrix, multiply by the coordinate of the image. It will take you back to the object coordinate. That is another shorter way in that equation that was done in KCSE 2020 Math Paper 2. A student was given the coordinate of the image, and the matrix that mapped the object onto that image. So in that case, just find the inverse of the matrix, then the inverse of the matrix multiply by the object, the image coordinate. It will take you back to the object coordinate. That is also another example where an object has undergone two successive transformation. Case is 2015, question number 21. As an object, it has undergone two successive transformation, transformation 1, transformation number 2. Then a student is asked to get a single transformation that maps the final image back to the object, like A double prime, B double prime, back to A, B, C. You'll find that that is a reverse. So the order of multiplying successive transformation is used. You just multiply in order, but that single that you get, you find is the inverse. Here is my illustration that I have the order here. When I take, it has undergone order R followed by N. In finding a single transformation, it is N multiplied by R. So N multiplied by R, it will map object to the image coordinate. But now, the one that will take this image coordinate back to A, it will be NR, then you find is the inverse of that matrix. That one will give us the single matrix that will map the final image back to A, the way I have stated here, that a single transformation that maps A double prime onto A is NR, the order of multiplication of the successive transformation, then you find it's the inverse in that order. The example is there, that one. This is an example that appeared in cases last year. Case is 2023. A point PXY is mapped onto that one by successive transformation M followed by N. Determine a single transformation that will map P prime onto this one. You'll find that this is an a reverse from image back to the object. So student will have to follow the order of multiplying the matrix, which is the second matrix multiplied by the first matrix. But now the answer the student get, find the inverse because it is a reverse from the final image back to the object coordinate, like that, instead of just going to other things. Then we have these things of latitude and longitude, which are where one of us asked about them. Longitude and latitude, student must master the vowel la, le, li, lo, lu. The la comes first, the lo is the second part. So the first coordinate to come across is stand for latitude, la. Then the second one is for the lo, longitude. The longitude, and the distance along the great circle is also known as the shortest distance along the great circle. But sometimes the question will direct, we are finding the shortest distance along where. You can check cases 2013 Math Paper 2 section 1. There was a question that they were given the shortest distance between 2 points, but it was along parallel of latitude. So meaning that if it's along parallel of latitude, you need to also follow the rule of getting the parallel of latitude. But in this case, the angle subtended at the center must be less than 180 degrees. Those who have seen a paper of Maseno, when you find that longitude different, the longitude different was giving something like 270. But the question was asking the shortest distance. So you find that the 270 will not give us the shortest distance. So the shortest distance will be given by an angle which is less than 360, which is less than 180. So getting 270, it is a reflex angle. So each angle that will give us less than 180, it will be that 270 which is reflex from 360, because our complete turn is 360 degrees. To get that smallest angle less than 180, to use it in getting the shortest distance along the parallel of latitude. So let us not commit ourselves that shortest distance is always along the great circle. No, the question will direct what you are going to do. That question that was asked where the latitude, longitude are not directly opposite, that was under navigation, 1995. Navigation, currently we are not doing navigation. We are just doing the other things that are similar to our students. So that one of navigation where we apply the sign of a half beta currently is not tested. So that one we can leave it for the sake of the sum that is coming in the next 1 month. Another thing here, this one I've already discussed about it, about this short distance. This was an example of Maseno. So the shorter distance in kilometer between A and C. This was A, this was C. And along the path of latitude. So you'll find that for along the path of latitude, I need to find the long difference. The long difference giving it to 70. But I cannot use this 270 because the 270 is a reflex, which will give me the major arc. And the shortest distance should be for the minor arc, which is 90. And that's why I have brought in the 90 decrease, like that, the one I've done there. This is an example of those things, all of those. Probability, I always say that probability can be not, those fractions cannot be simplified or they can be simplified. Nobody will deny you their mark. So you can give it in simplified form or not simplified form. But when you are representing those fractions on the branches, don't simplify them, because for an example of picking, maybe like that one of cases in 1995, it was done wrongly. It was given in terms of ratios. So the ratios, you cannot pick them. If I have 4 pen, red pen, and I have 6 blue pen, you'll find that the total pen there are 10. So the probability of picking red, it will be 4/10. Don't simplify that 4/10 to be 2/5, because if you pick for the next stage, you should be picking from the original, which was 4, not 10. So on the along the branches, kindly don't simplify those fractions. Use the fraction the way they were originally in that question. We have this commonly tested question that has been consistently tested on proving that are the students aware that the sum of the probability is 1. They give with a constant k. It came last year, KCSE, where there was a typo and one of the value was omitted. So if the value is omitted and those values are for the probability, you just note that the sum should give us 1. Then you get that k, that unknown value, like that one, this one. You have been told that the probability of R is KR, like that, Ivo, then wakataka the value of K, like that. So the sum of the probability, it should be 1, like that. Integration, I've already mentioned that in integration, being that it gives exact, let us leave the answer in fraction, the simplified fraction, but don't give the decimal unless it is exact. But if it is not exact, kindly don't give your answer in recurring decimals, because sometimes we normally advise that you can put that recurring, but during marking, those examiners might be faster and they cannot maybe see that recurring symbol. So please, instead of writing the recurring, just write the whole fraction in that order of like 1/3, if it is 1/3, like this one. It was 85 whole number 1/3. Don't write 85.3, then you place the recurring at the top. Maybe that recurring can be invisible, which the examiner cannot easily see it. So let us discourage them from writing the recurring, even if it is the correct question. Then lastly, we have the open-ended question. The last open-ended question is the question that does not restrict a learner. Like this was cases around 2014, where students were asked that just evaluate. Then the student was struggling to come up with the loss, in which the question didn't expect the student to use the loss. So if it is just evaluate, students are allowed just to fit that value in the calculator and then just go one step from this one and then give the answer. The student will just get that answer correctly the way I've done here. So maybe the law that could be applied here was only to remove that power using the power law. So when the student use the power law, the remaining just fit in the calculator directly the way they are, then get the answer 0.82, then write in the 4 significant figures as the question has instructed, the accuracy level. Good. Then next we have questions that are answered elsewhere. Like in section 1, we were advised that don't cancel any question in section 1. In case you have another opinion, you can just go and write somewhere, so long as that question is numbered correctly. You just number, if it was for question number 2, just number correctly that question number 2. It will be marked. But if answered elsewhere and it is not numbered, the student will not be marked that one, because we don't know if they work for what question. So it can be marked as the workings for that question in which it is under space, that space. So you make sure that if it is answered, it's question number 3, and you have answered under space of question number 18, you number it as question number 3. Then if it is a paper, section 2, a question on angles, just writing in that angles, just writing that, fitting in that diagram, then inakushinda unaachana nayo, it will be counted as a question that has been attempted. Then a serious case, another one is on the linear programming. The linear programming, let us advise our student that those lines, they should be named. Is a line, let them now name them. It is the line of what? Then when they are naming, they don't use an inequality, they use equal sign. The reason why we want them to name it that, if they fail to name those lines, if one of the line is out, the whole graph goes wrong. But you'll find that when the student name, and maybe there are 4 inequality, and one inequality is the one that has been messed up, the 3 inequality will be marked correctly. But if one of the inequality, all the inequality has not been named, and one of the inequality is wrong, the whole figure, the whole drawing goes to 0. So, but naming, a student at least can score a mark on those graphs. So advise them to name those graphs. So the projection, I had here what is can be projected. What can be projected like this. I don't know if you can see. Let me try to enlarge. So when you check this trend, when you check the trend of the KCSE, there is some topics like commercial arithmetic. It has been consistently tested all the way from 2011 up to current years that we have. It has been consistent testing. So I'll share this analysis. I'll share that one. We'll just share on the wall. We don't have a problem because of the end of the time. I'll just share on the wall so that you can check which question that has been consistently tested. And now what is your projection you can make from that consistent of that topic. Check this commercial arithmetic, the way it has been tested all the way from 2011 up to the current year, last year, KCSE. Question like vector 2, you can take how consistent has been tested. So this question will be shared, this document will be shared on your wall so that at least you can go through it to make your own projection on your site. So that marks the end of my projection. Let me turn back the microphone to the moderator so that we can answer a few questions before we allow the second speaker. Yes, kindly.
Thank you. Thank you, Senior. Members appreciate our presenter. That's a good one. I saw someone saying, let's have a 5 minutes break. Because of time, we may not have that break. We are rushing against time. So it is 9:21 and our second presenter is on the queue. So I will only take 3 because I want to start at 9:30. Let me take 1, 2, 3, 4. Chris Wabomba ndio wa mwisho. The rest now may come after that because of time kindly. Lewis, alafu Naomi, alafu Maxwell, alafu Chris. Ukifuatana in that mimi. Chris ndio wa mwisho.
Thank you for the nice presentation. I have a question, and this is the question. You have seen that the distance, the shortest distance is not always around the great circle, so I would like kindly elaborate about it.
Good. We have said that the shortest distance is always along the great circle. Great circle is along the longitude. When you move by a longitude, that one will give us the shortest distance. That is what we have. Like when you pick 2 points, you can pick a point A, 20 degrees north, 100 degrees east. B, 20 degrees north, 80 degrees west. You can get the distance along the great circle and the distance along the long latitude and compare. You will find that the distance along the great circle is the shortest distance ever. But I've said that with the current testing of the neck, they'll instruct the learner that we are following which path. It can be the shortest distance, but along the latitude. So if it's along the latitude, there is a hidden question there where along the latitude, we need to get longitude different. And I've added that if the longitude difference is more than 180, that is not the shortest distance. That one is the angle for major arc. So you find the angle for the minor arc that will give you the shortest distance. I think your question has been answered.
Yeah, it has been answered. Then what about using this formula of sine and cosine? That's more formula.
That was a formula in 1995 KCSE navigation. When you check there, it was under navigation where student was where those students of those year they were applying the sine of a half beta is equal to the sine of a half alpha, the cosine of theta, where beta will be our latitude different. And alpha is the longitude different. And the theta is the common latitude the point are lying. So that once you get that beta, you substitute in the formula of the shortest distance. But I've added that the examiner have instructed shortest distance along parallel of latitude. Case is 2013. Check that question section 1. The shortest distance along parallel of latitude. If they instruct parallel of latitude, you follow for the parallel of latitude, which is for longitude different. Good. Are you okay?
Thank you.
Welcome.
Madam Naomi?
I have, thank you for the presentation, Mr. Nyikuri. I have a question just on longitudes. I have listened to the last presentation between you and Lewis. I have learned that it is good to follow instructions given in a particular question.
True.
But when it comes to distance along a great circle, especially when longitudes add up to 180. Actually, Kelby says that is the shortest distance possible, which is true. But when the longitudes do not add up to 180, I just had some formula here. I'm wishing such things don't come to KCSE. I've listened to better. I don't know alpha. I don't know what there. So when the two the longitude difference is not equal to 180. Points are on the same latitude, but the difference in their longitudes is not equal to 180. So how best can we get a distance via the North Pole or via the South Pole? And then I wanted you to give me that slide. I really need that question where the longitude difference was 270.
Maseno paper. If you have access to Maseno paper somewhere.
No, you will send me.
No problem. Good. I've mentioned that the cases of finding what's called the latitude different. We have 5 cases, but the 5th cases, it was under navigation. The first case is when the longitude, the latitude are in the same hemisphere and on the same longitude, you subtract. The second case, the latitude are in the different hemisphere on the same longitude, you add. The third case is where the latitude are in the same hemisphere and they are lying on directly opposite longitude. You sum the latitude, then you subtract from 180. The fourth case, the latitude are in the different hemisphere, but they are lying on the directly opposite longitude. Directly opposite means that their sum is 180 and they are in the opposite side. You need to sketch so that you can identify that angle. That one is easy. Now the 5th one is where these things of beta are coming in, and those one were for navigation. Currently, the navigation part is not in the current syllabus. And I mentioned that the last time it was tested was case is 1995. Though it appeared case is 2013, but there was an additional instruction that the shortest distance, but along parallel of latitude. Parallel of latitude. And I said that along parallel of latitude, that angle that is giving that arc length, it should be for the minor. That one is the one that will give us the shortest distance. Thank you.
Thank you so much.
Welcome.
Maxwell, then Chris. Maxwell is not there. Chris?
Hello, senior.
Yes, senior.
I wanted to add, we can have the longest distance via the great circle or along the great circle. For the case where the 2 points are in the same hemisphere, let me give an example of 50 degrees north and 30 degrees east, and then 50 degrees north, and then 150 degrees west. If we were to get the shortest distance along the great circle, then the younger at the center will be 180 minus 2 times 50, which gives 80.
Yes.
So if we go to the other angle, that is 360 minus 80, which gives us 280, that can then give us the longest distance along the great circle. That's just what I wanted to add, if the examiner thinks that way, if that
Very
case
good.
can be
Very
done.
good. You know, in carry the distance, we are dealing with arc length. Arc length. So the longest distance is the arc length for major sector. And for the minor sector is the shortest distance. And that is what I think Chris has mentioned. For the major arc, that is the longest distance. For the minor arc, that is the shortest distance. But when you're comparing 2 points, you follow via longitude and another one via parallel of latitude. In comparing the 2 points, the distance along longitude is shorter as compared to the distance along the parallel of latitude. Good. Thank you for that additional information.
Okay.
Oh, thank you. Welcome, sir.
Finally, we have Margarine girls.
Yes. Make it. Yes. Hurry up.
My question is under probability. What if you have been given a question which is in a decimal point, but you turn it to work with using fraction? Is it acceptable or?
Kindly, Mwalimu, to that student, you can now amplify that question well. The student is far away and there's an echo behind.
A question is under probability.
Yes.
What if you have been given a question which is in a decimal point, but you turn and you work it through fraction?
Very good. That's a
Is it
simple question.
acceptable or?
So is it advisable to write decimals into fraction? Yes, it is advisable. This decimal can be written in fraction like 0.8. 0.8 is the same as 8/10. That one is acceptable. You'll not be penalized that mark. So it is just true.
Okay, thank you. I
Good.
think we it's 9:32. We can now move to the second presenter. Senior Libendi, confirm that you are here with us.
I'm there, senior.
Good evening. I think now you can take the stage.
Allow me to go straight. Colleagues, good evening and welcome to this presentation of the last part of our webinar today. I'm Libendi, a teacher of math and physics. So I'm here to share with you and to things that we need to cover. So I want to go straight to mention a few things before, just first as to agree with the senior Nikul. Then some 7 things I want to share with my colleagues so that as you go on preparing our candidate before through one key, I'm looking at the key trends in the KCSE, speaking of KCSE Math Paper 2. I'm examining Paper 2, the things that we just mentioned we are getting. Allow me to take you through very fast, then I'll go back to the calculator. The first one, there is demand of applications. Colleagues, let us encourage our students to practice on questions involving applications. They are not that direct, but we apply in terms of, you are looking at the application questions. That's something I wanted us to get very clearly. We practice on application questions. Number two, there's a trend that's also coming in, that the examiners, they really want students to be exact values or precise workings required. For example, when a student is to give an exact value in terms of, for example, a square root of 4 and a root of 5, the exact value remains to be the square root of 5, not the number, I mean root 5, and not the number. When you're allowed to use a calc to find the square root of 5, you leave the answer in root 5 form. Or for example, it's a fraction, then you leave it in that fraction form, it will be exact. So these are that is very clear. And if you look at last year's paper again, it's really coming out very clearly. There's also the topics becoming so wide that actually even predict it's now becoming difficult. We are increasing the scope, and therefore Mr. Nkudi was saying, let us also encourage learners to prepare widely. Let us not go down and say that prepare on this topic is coming. No, let them prepare widely so that we don't again disadvantage them. So the examiner is very keen. They are testing almost everything that you've learned. Then it's on higher order thinking, the hot questions. Now where we come in. And let us also assist learners to deal with the difficult questions, avoid simple questions. So more multiple step questions are required. Of course, a lot of reasoning is coming in. Let us encourage our candidates and students start preparing that difficult questions so that they're able to interpret and even be able to do the right marking instead of at simple concepts. Consistency in marking and allocations, again, this one is coming out. There's a question Nikul shared about commercial arithmetic. Actually, these topics, they are coming out every year. These topics, they're coming in because students are failing. A report keeps on saying, let the teachers go and reteach. And the NEC will still bring the same questions, similar question, with the same allocation of marks, 10 marks. Therefore, don't brush off a question topic because it was tested last year. We are going to have a roadshow because these topics can still be tested. Therefore, let us prepare them well. Second last, I'm looking at the increased difficulty in some questions. I looked at 2022 KCSE paper 2 and also look at 2024 paper 2. You realize that these exams are a bit difficult. Like paper 2 last year, you can imagine the first topic, the first question coming number 1. It was about sequence and series. A topic that is difficult for the majority of the students. The intention of the examiner was simply to put off the candidates so that they can slip the first page and automatically they lose their control. They end up not doing very well. I want us to encourage each one of us must prepare difficult questions. Let us hard them so that we can, when you train very difficult or train hard, we are going to fight easily when it comes to KCSE. Let the candidates prepare with a difficult question. Lastly, we've seen a trend where the examiner is going back even to 1990 and pick small questions in 3 and bring them back. I liked the way Senior Nyukuli was able to bring out the patterns of the topic tested in Form 3, and Form 3 is taking majority share of the paper. And therefore, let us prepare students. Don't allow a candidate to go sit for exam without going through Form 3 work. Form 3 work is carrying almost 50% of that paper. Therefore, we have no choice. We need to do this. Let us support our candidates so that they're able to do that. I felt, let me share those 7 areas with you so that we are able at least to prepare the candidates well, that don't say we didn't do our part. Don't give them simple questions. Kindly put those points in order, in practice, of them, that one under the new trends in the setting of KCSE. I now go to, thank you very much for that. I'll go to my area. I'm supposed to do a simple presentation around 20 minutes. I will be a bit faster, but today I'll also try to be in accordance so that we try and understand. Now, just on Friday, we had the training on there's a new launch of a new calculator, which is coming in, and it's called FX82CW. That one is a new machine, is coming. It's already been admitted by NEC, and it's coming. It's coming because of the CBC. And therefore, colleagues, I thought it's also good for us to understand this MS82 because I know all of us, we are immigrants in ICT, but we can agree we have no choice but to follow the natives, now the new, the ones that who are coming. We need to understand how to deal with this machine. This calculator was brought in so that can assist learners to understand on how to solve questions. Senior Lion told you to carry your calculators. I hope you have it. Kindly, I want us to go through this. Some few areas I want us to look at. Number one, because let's realize that we also have students attending this session, and therefore allow me to tell students and the teachers at large, because we are the ambassadors, please check the calculator the learners are using. I want to share the two recommended calculators. Number one is this one. It is FX82 MS, the old version, by the way, not real in the market, but if a learner has this one, then of course that's a better deal. Allow him or her to use. The second one is which used to be called the TL, but now this is Casio, made from Thailand. This one is allowed. It's a calculator that's allowed. So it's very fragile, but it is allowed. Now we have calculators which is not going to allow, unrecommended one. We don't encourage this one in class. Don't encourage this second one in class. If you have this one, if you've carried this is a wrong calculator, don't have it in class because it is going to mislead the learner. This is another one for Mamamboga. This is a wrong calculator. Please let us avoid it at all costs. This is another one which is not allowed. I've also seen very funny calculators. These ones, they are not allowed because they will mislead our candidates. Let them use FX82 MS or the TL, former TL, which is under Casio, made from Thailand. There is this new one, I'm telling you, it is coming. We did a launching on just the other day from Casio, and we have everything, and it's a nice machine. This looks on the home page. You'll now be able to get it very soon. With the CBC coming in, we are going to have this calculator with you, and I can assure you, if you have a problem with FX82 MS, then CW will give you headache. And we have no choice because those guys are coming, and they're coming with the ICT in their heads. We need to support them. Allow me to go straight and teach you and take you through some few things about these topics where we can use calculator, and they are using for confirmation. Remember, that's a disclaimer. These 6 areas: angle conversion, length of a line, binomial expansion, quadratic equations, statistics, completing the table. I want to deal with some few, maybe some I'll leave it, but again, we'll share the slides. We'll share part of the slides so that maybe for those who want to get the steps, we can follow through. I want us to go through this. Kindly take your calculator the way it is, and when you look at it, you are supposed to switch it on. After switching it on, there are things that are going to be. So the first one, I want to do the conversion of angles from degree to radian. And this one, I want to do using this. I want to do using this one. Let me use my platform here. This is my calculator I'm using. I hope I'm able to be seen from the other side. Moderator can confirm if you're able to see my calculator on the screen.
Yes, it is okay.
Thank you. So members, this is the calculator that you are using, the one that you have. When you go to shift, then you press mod, then you press is equals to. Then you will see something nice. Sorry, I go to shift, mod 3 is equals to. That's how to reset a calculator. Let us encourage all our learners. Before they use any calc, they must reset. There's something that happens with the calc if you don't reset. For example, when you press mod, then your calculator will bring SD reg and whatever. Then I'm looking at this point, degree, radians, and radians. When you press mod 3 times, it is degree, radians, and gradians. Once you press 2, the calc will read the R inside. If you go and check what is sin 30, you'll agree with me, it's going to give you an answer. This is a very wrong answer because the angle is in radian. Our students don't know the difference between radian and degree, and somebody could have changed the function. Automatically, our learner will have it tough. They'll end up posting wrong answers. We've seen in marking, student has the correct method, but the answer is wrong simply because the calculator was used in a wrong mode. So let them learn how to shift mode 3, clear everything, you reset all. I'm through with that part. There's a part I want to show you now a bit, converting of angles. For example, we know how to convert. If I want to convert 1 radian, how many angles, how many degrees are that? I need to press 1, then come to shift, then press answer button. Answer button has DRG. D stands for degree, 2 in a radian. When you press 2, you can see it is pi 1 radian. Then just press is equals to. Let the learner be able to get this value, 57.29 degrees on the screen. It will assist the learner to stay alert and get the angle correctly when it comes to conversion. I repeat, for example, if I want to convert 180, which all of us we know it is pi radians. So I convert 180 degrees. So I press 180, or let me convert it back to radians. If I have pi radians, so I go to shift, pi. Okay, I go to shift, pi. I want to bring it radians. So I go to shift again, I come to DRG, I press 1, 2. So I have pi radian. All of us, we are aware that pi radian is equals to 180. Once you press here, it will give you 180 degrees. That is how to convert angles using a calculator. So no learner should be able to fail that question if asked to convert, change the angle from degree to radian. That one, I felt that let me show you so that you can also be able to share with them and they'll be able to follow through and get it right. Changing angles from degree to radian, also from radian to degree. It's a very common question in paper 2 that we need to learn. I want to go to the next part. I'm through with that one. Determining the length of the line. For example, this, and this one is for the students to follow through and also the teachers. If I'm given line AB, the coordinates is 2,6 and also 12. I want to find the length AB. Normally we take 12 minus 6 squared plus 8 minus 2 squared. The answer will be root 72, which will give you a very good answer. I want to encourage learners and also the teachers that when you give this kind of a question to the students, we can use a calc so that you don't over struggle again. Tulisoma kitambo sisi walimu, kazi yetu ni kurelax na make sure wanafunzi wanafanya hii kazi. What we need to do, it is very simple. There is a poll button, poll. If you are able to see from your screen, there's a poll, P-O-L. I know your calculator is the basic one, so getting poll is very simple. But for me, I'll go to shift. I wanted to press this. It will indicate poll. After writing poll, you just type it was 12 minus 6. 12 minus 6. Then you put a comma. Use this one as a comma. Then you go back again. It was 8 minus 2. Then you close the bracket. The way we normally write in the modular formation, but with the squares. Calc, just press poll, and then you insert those coordinates, different, you close. Once you close, you press equals to, you are going to get an answer. If you get that answer 8.48 whatever, this is the square root of 72. If you square that answer, you will get 72. Members, that's how you're supposed to use a calc to find the length of a line. The angle that line makes to the x-axis can be extracted from alpha. When you go to alpha f, you will now be able to get angle is 45. If you do the tan inverse of that gradient, which was 1, the angle becomes 45. In short, I'm confirming it is possible to use a calculator to find the length of the line and also the angle the line makes with the x-axis. I'm through with the second part. I've taken you through 2 areas. 1, the length of the line, and number, angle conversion. Good. I hope I'm not very fast. Now, I want to go to the next part. And the coefficients in binomial expansion. I happen to have a student who didn't have a problem and I don't have mathematical table to get the coefficients. Colleagues, when students, after teaching that Pascal triangle, let students also through other methods. How else can they be able to use a calc to find the coefficients? For example, there's an LCM button on your calculator. NCR. It is used to obtain the coefficients. NCR, it is there. You can see imeandikwa capital C. When you press inaandika capital C. This button, for example, if it is given 1 minus 2x power 6, you want to find the coefficients. It is very simple. This is what you do. You just press, so let me exit this and go back to the calculator. This is my calculator now. What I need to do, I first press 6. 6 is the highest power we have. Then I go to shift, then press that button ile nimekuambia saizi imeandikwa NCR. You check yours, I think is around there, I combine, but you can press that NCR. Sijui kama umeiona. Mimi I can sign it is here. When you press inakuandikia C. Once you do that, you start with 0. When you press 0, you press is equals to, it will give you coefficient is 1. Then when you go to close, so it give, when you keep on changing that, 6C1 will give you coefficients. C2, it will end up giving coefficients, those coefficients. For example, this is what I've said here, that when you do that, 6C0, it will put a coefficient 1. 6 una replace your 0 and 1, it will give you all the possible coefficients that you need. Let the learner explore and be able to get those coefficients. It is very interesting for them to do that because they'll be able to see how to use that calc, and they'll get interested on to follow the usage of the calculator. I hope that one can be done by most of us comfortably, getting the coefficient of the binomial expansion using the calculator so that they don't struggle. I go to the next part. The next topic, that's topic number 4, quadratic equation. This one will be a bit slow because it's very complex, and it is very encouraging for most of us to be able to get this, because when I'm able to solve a quadratic equation using a calculator, then I'm helping my learners to get this correctly. This is what you do. This quadratic equation as it is, there is a mode for quadratic equation, and you need to be there. When you do this, and I want you to follow through my working here. This is the calculator. So you first shift mod is equals to, you reset all. Then you press mod. Your calc press mod itakuandikia comp SD reg. Now let me go. I'm now here to the reg, which is by 2, but yours is 3. When you press that, itakuandikia ln, log, and exponential. Linear, logarithm, and exponential. You press the revolver button on your right, the calc. It will give you power, inverse, and quad. Number 3 is quadratic. So what you do, you just press that 3. You are now in a quadratic mode. Then you go to the question. You first press alpha, C, you put a comma. Then you now replace the equation. You type that equation as it is, alpha C squared minus, it was 5, alpha C, then plus 6. I've just copied that equation as it was. After that, there's this button called M plus here. We press it 4 times. 1, okay, I didn't clear, but when you press it once, it will give you 1, 2, 3, up to 4. Once you get that, you proceed and extract the values. So when you press M plus 4 times, it will give you this. After you type that, then you press M plus 4 times, itakupatia N is equals to 4. Ikishakupea N is equal to 4, you need now to press 0, shift, 2, then una press cursor to the end. You will realize you are going to get x1 and x2. Once you press 1 and press is equals to, you get the value of x to be 3. For me to be able to retrieve the second value of the quadratic, I go back to 0, shift, 2, cursor to the end until you get x2, press 2, press is equals to. The answer will be 2. That is how to use a calc to find the quadratic equation, the solution for the quadratic equation. This is very good for the learner because atenda ku understand that he or she cannot give wrong answers. You must have the correct answer using all means. Then of course you can follow through the work. So I'll share this part because it's just a simple step, or you can take the screenshot. You can also practice, and I know you'll be able to do this with your students, and you'll encourage them to use a calc. they'll know is a very powerful machine, a very powerful tool in teaching and learning. Lastly, I want to look at statistics. How do we get the standard deviation and the mean of data using a calculator? This is what I want us to see. And for group data like this one, this data that you have, if you have this data, I've seen you're going to talk about that very much, and I were able to even to go the histogram. But now my interest is for learner to be able to get the correct answer paper 2. So if I'm given data 40 to 44 all the way up to 60 to 64, I can see the frequency there. Remember, the first thing I need to do is to get the midpoint, which is already here. I've done it for us. So after getting the midpoint, you need to access your calculator and to the data. And it is a very simple thing. This is what we do. And I want us to follow because it's not difficult. You go to your calculator. Now with this how do you call it? With this data now, the midpoint and the frequency, I need to go to my calculator and then just insert. So I'll go to shift mode 3 is equals to, I reset everything. Then I go to my mode, I change to SD. Your calculator is 2. So once you indicate SD, then I start now entering the values. So I'm supposed to enter 44. Then I go to shift, comma button. I check the frequency of that one was 4. I press M plus 1s. It will give me N is equals to, for your case, N is equals to 4. So when you do that, let me exit. So 42 as to access this. So when you press 42 shift 4 M plus, N is equals to 4. Then 47 shift 10. Remember, I'm entering shift comma 10. I'm entering 10 times. You press M plus 1s, it will add into 4. So when you do that, you repeat the procedure all the way up to 62. You'll have entered or you have gone through all the values. You've done the tabulation in the calculator. So it applies N is equals to 40. Once you get N is equals to 40, you now have the data in the calc. From there, just proceed and extract the values. Now, when you go to shift 2, you will get X bar and then the sigma N. This is the second part. That's 1 is X bar, that's the mean, and 2, it is the standard deviation. Let the learners be able to extract the mean, which is by pressing 1, and then the standard deviation by pressing 2. That is how to confirm their answers if they are correct or wrong. Let the learners not submit the wrong answers. They must check and confirm. And by the way, if they can scribble things and get the correct answer there, we are also sometimes tired of marking these things. Let us also be very so that they don't give us always every answers. Let them have the correct answers to them so they can work backwards. These students are bright. They can do this. Show them how to do, empower them. And I know they'll be able to do. I think my last part, I only have 3 minutes. I've taken 5 topics. The last topic is I want every student in this country to be able to get this mark. Filling of the table, completing the table. The students are having struggles in completing the table. I want us to see something here. How do we complete the table using a calc? You will be able to extract these things. It's not the trigonometric function. It is very simple. This is what we do. I want us to have this part and finish with it because you will be able to practice, and I hope you've been able to take the screenshot so that you are able to practice at your free time before you go to the students. This is what we do for the calculator completion of the table. I do this, and I want us to follow this. Now, from this data, first you check the data. It is from 0 to 15. You check the range. The range of this data is 15. So what you do, you save negative 15, the variable x. You know how to save. You save negative 15 to the variable x. So this is what you do. I come to my calculator here. Then I say negative 15, then press is equals to, you come to shift and store x. Itakuandikia kitu kama hiyo. It will indicate negative -15 into the, what you do, you use this revolver button, cursor, to move the cursor backwards, so that now the negative can start blinking. Then you go to Shift, Delete. Then you delete until you have this 5 blinking. Then you just type x plus 15. Now, why are we doing plus 15? So that negative we have, it will end up giving us that equation. Then use the cursor to move the cursor to the front. Then you come to alpha, access this button, the 2 dots. Then you just type that equation in front of it. Colleagues, this thing is very simple. You just type 4. It was 4 cos what? Cos 2x. When you do 4 cos 2x, 4 cos 2x, then you go back and access your x. Then again, you type the second equation, which was 2 sine, open the bracket because of the numbers it is, 2x, then plus 30. Then I can tell you that you are through the work. What you need is now just to press the equal sign. Once you press the first one, inakwambia the first equation, when x is 0, the first function, the value of y is 4. Then the second value, the value of y is x is 1. When x is 15, you just press is equals to, it will give you those numbers. You are now filling the table to the nearest exact values. You are getting them there. When x is 30, you press is equals to that, is equals to that. You keep on continue until you complete the table. When you check, it will keep on adding those angles based on the range that you gave. So you end up getting that table, you will fill the whole of it, complete it without any problem. If learners can practice this every time, you can be assured they will not have any problem. That one I thought is also good for us to be able to know, so that we can assist our learners to learn on how to use the calculator. It is exactly 10:01, and senior learner told us the program will go up to 10 exactly 2 hours. I want to stop there and invite questions if there are any for the members before I can mic back to senior lion to moderate and close.
Thank you, senior. Thank you, colleagues.
Thank you very much for being very good for it.
You have seen a calculator there. Okay. Okay. Yes. Tumeambiwa this very simple. Yeah, it's very simple, very straightforward. See what tunajua. Uko na calculator but you don't know all those functions. So tafute square root, square, hivyo tumalizane nayo. Someone was kuna mtu ameuliza sijui nini hapa, let me see. Good. The learners score full marks with the shortcuts in the calculator. Ameambiwa hapo chini, calculators will help the learner in proving what he has got is correct. Inamsaidia tu kuprove kama.
Thank you. That's a correct answer.
Yeah. So let me go straight. I have a few questions here. Felix, Maxwell, Fred, and Maulid. In that order, we finish. Tomorrow is Monday. I know kuna TODs wako hapa. Felix, Maxwell, Fred, and Maulid. In that order.
Okay, thank you. First of all, I want to appreciate the presenter. That has been really great presentation on how to use the calculator. And like you said, the moderator, very simple. But I want to say that the topic of quadratic equation in the last topic, I think the presenter was very fast. And number two, the internet was breaking, and so some of the things that he was mentioning couldn't be heard clearly. I was wondering if there is a way this could be shared maybe later on, so that we can also give to our students, even those ones in Form 2, Form 3, and then they can get to learn as early as now. Thank you so much.
Okay, thank you. That was a
Noted.
request. That's noted. Maxwell.
Okay. Hello.
Yes.
Okay, thank you. I'm being convinced that my gadget is not digital enough, because at the first case I wanted to ask a question, but I was not able to. Okay, to my questions. Okay, the first one on income tax. Maybe you shed more light, because at that point when it was being explained, my internet was not that good. Then on probability, are we advising students to simplify the last answer, but not to simplify the branches? That is the probability of the branches. Please shed more light on this. Thank you.
Hi. That one will be responded. Wacha tusikie Maulid, then when ya mwisho ndipo responded all together. Maulid. Maulid Shikari. Okay. So the start question of income tax. I think Simenyikuri, you are here, you presented it.
Thank you. So the income tax, I've said that the taper has been expanded when you take it from the cases 2020, where we have an additional things of things that are exempted from taxation. Initially, we used to have a debate on the nominal rent, but currently, as the teachers are not being housed by the government, at least the nominal rent is not being captured well in the neck. But we have these things of deductions in our pay slips, like housing levy, where the housing levy, when you check it well, it is being taxed 1.5% of the gross income, and it is exempted from taxation. We also have those things of share, which is taxed around 1.75. So I'll say that when it is exempted from taxation, it means that it is not part of the amount to be taxed. And the amount to be taxed now is what is referred to as taxable income. And this taxable income is obtained from the gross income. The gross income, whatever you have, all in fact in total, just like a teacher who can be running a supermarket outside and still is earning the amount in the school. The amount that you are earning from the supermarket outside the school, you do not take it to the TAC to pass through that taxation table. No, that is your own money that is non-taxable. So when you take that money plus what you need to earn on your payslip before deduction is what's called the gross income. So from the gross income is where we'll subtract NANI, taxable allowance, where we subtract any amount exempted from taxation. Now the balance is what refer as the amount to be taxed, taxable income, the one that will pass through the taxation table. I think that one now I'm clear. I can answer that one of probability also before I get another question. Probability, I've said that probability we allow if students give the final answer in an simplified or simplified, we don't have a problem. But you don't give the decimals if your decimal is non-terminating. My concern was on that branches. The branches, even if it is something to be simplified, you are not supposed to simplify it. I'm taking an example of 5 pen, and something like 11, 5 red pen and the 10 blue pen. You'll find that the probability of picking red is 5/15, which is the total outcomes. When you simplify 5/15, it will take you back to 1/5. But now, if you are picking without replacement, the one who have 5/15, when you pick one pen, it will go to 4/5.
14. But now, the one who have simplified to 1/5, when you pick one pen without replacement, what do you remain with? Will you remain with 0 out of 4? So you don't simplify. It only simplify that in terms of that one, unless you need maybe to convert that amount picking also in terms of the ratio, the part in which that subtraction in picking represent in terms of ratio. Before now, you subtract in terms of ratio. That was my explanation on probability. I hope you got it now, right?
Okay, thank you.
Good.
All right.
Hello, Mr. Puri.
Yes, senior.
How are you? Long time.
I'm more than fine, senior.
I have a question
Ask me that question.
on income tax. You see now there is this element where the examiner will make it clear to us, to the learners,
Yes.
that maybe if it is pension, then the examiner will say it is exempted from taxation, isn't it?
True, yes.
Now, suppose you are just given that pension, and then you have not been told that it is exempted from taxation. Do we use now the knowledge we have that pension should never be taxed, therefore we deduct it from, we are finding taxable income?
Very good. Now, as you started your statement very well, next, the next question, they normally say so that the question does not look ambiguity. There must be something that is directing that learner what's supposed to be done. It cannot just give the pension scheme, then without that additional word of it is taxable or is exempted from taxation. If we try to imagine from outside, we can raise so many questions, confusing the students who are there doing an exam on 11s. So let us just think that the NEC will direct us. If it is exempted from taxation, they will say, like housing levy, it is taxed 1.5% of gross salary. If it is your basic salary, what I say, of basic salary, exempted from taxation, like that. If it's an allowance, they say non-taxable allowance. Now, if it is taxable, they just keep quiet, an allowance. So you treat it as a taxable allowance. Are you okay?
Noted.
Good.
Okay. Thank you. Thank you all. I want to, there is a Madam Beatrice Awino. Are you with us, Madam Beatrice? Let me see. Madam Beatrice Awino. She had raised mkono juu, so I wanted to confirm if she's okay. Okay, Fred Odoyo.
Yes.
Close for us the meeting with a word of prayer.
Okay, we are praying. Hello?
Yes, yes.
Are you getting me?
Yes, of course.
Okay, we are praying. Our Heavenly Master, we thank you for the opportunity you've granted us, Father. We thank the representatives who have done a wonderful job. And we also thank the organizer of this presentation, Father. We now want to go to rest, Father. Be with us. All I ask in Jesus' name, I pray and believe. Amen.
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 Is Odoyo a Christian?
Thank you very much.
Anakwama akiomba.
Ako na wasiwasi.
Amen. Amen. Amen.
Amen.
Hapo mahali pa calculate ndio afaa watutumie hizo notes.
Yeah, watume hizo za calculators. The presenter was too fast.
Yes.
AOB.
Are you in the post?
Msifanyie wanafunzi KCSE walimu, sawa? Utachikwa na uproduce umesikia?
May you send a probability note, please?
And even topics, topical non-safe. Place your votes. Kidogo. Kesho nimeweka exit meeting. Kesho niko last time niko walienda kwa Marbi, nimerudishwa bati nilikuwa Arbisi nilikuwa kwa kina sana kama hawako on classroom next to strike classroom.